Okay, so I'm going to go over figure 15.1 and 15.2, which are related from the book. Okay, so it's a sequential game, which means, someone's going to move first and then someone will move second. And the way the drawing is set up is that whoever the first mover is going to be the person at the top of the chart. So in this case, it's labeled entrant, and that entrant would be the first mover. So the entrant, as the book says, they have to decide whether they're going to enter the industry or not enter the industry. And then once they decide, so we can draw that. So we're just going to put in for enter the industry and then out for not enter the industry. And then once they decide whether or not to enter, then the incumbent firm or the existing firm has to decide whether to fight the new entrant or accommodate the new entrant. So usually we call the first mover just player one. In this case, that's the entrant. And then the second, in this case, is the incumbent. We just call them player two usually. So I'll just label them incumbent. And then fight or accommodate. Okay, so does that make sense so far?
Yes.
Okay. So then the payoffs are what we put at the end of all the branches. And the first number that's at the end of the branch corresponds to player one. I don't know if that was totally clear or not. In this case, I'm just going to extend my branch a little bit. The payoff is 0 and 10. So that means if the entrant decides not to enter the industry, they're going to get 0.
Okay.
Because that's the first number in the payoff parentheses. But the second number, which is 10, is the payoff that goes to the second player, which is the incumbent. So the incumbent is still going to get 10 because the first person decided to stay out of the industry.
Okay, that makes sense.
Okay. Now, if the entrant decides to go into the industry, then the incumbent decides what to do. Either they're going to accommodate or they're going to fight. And so the payoffs will differ. So if they fight, the payoffs are given as -5, -5. So that means both, yeah, they both get the same thing, which is negative.
So what would be an example of someone essentially fighting somebody entering the market? Would that be like?
It could be like trying to compete on price, like lowering prices too low. It could be like negative advertising. I guess it could be, just any strategy that they think will help sink the new entrant.
Okay.
And then accommodate. In this case, their example for accommodation is keeping prices high, like not trying to start a price war, basically. So if they accommodate, then the payoffs are 5 and 5. So they both get 5. So they're basically splitting, splitting the existing market because the incumbent gets 10, but when they're in there by themselves, and now they're splitting the market essentially.
So the numbers that they're using is just essentially in a perfect scenario, not necessarily.
The numbers they're using are hypothetical.
Okay.
So it's just kind of, yeah, like a typical scenario, but they're still hypothetical numbers, right? I mean, what is 10? Is it really dollars? It's probably more like, oh, $10,000, or, it depends on how big the industry is, what those numbers actually are. And so they're hypothetical numbers, but they're just trying to show that, okay, well, if the entrant decides not to enter, then the incumbent is going to get the whole market, whereas if the new entrant comes in, then either they're going to split the market, or if they try to fight one another, they could actually end up hurting one another potentially.
Okay, yeah, that makes sense now.
So that's the setup for the game, and then to actually solve the game, which means we want to find an equilibrium. When you have a sequential game, meaning this tree setup, you actually want to work backwards. So we're going to start with player 2, the incumbent, and we're going to say, okay, we're going to look at their payoffs. And this, if they accommodate, player 2 gets 5. If they fight, player 2 gets -5. And we just say, okay, they're going to pick whichever gives them the highest payoff. So, right. So in this case, it would be accommodate. So I'm just going to mark that as the chosen path. So now we know what's going to happen at this point. They're going to accommodate. So let's just ignore the part of the tree. I'm going to cross it out with a different color. Ignore this part of the tree because that we've already decided isn't going to happen. And now, working backward, we look at the entrant, because the entrant is the next decision. They have to decide whether to go in or out. And now they are comparing the 0 to the 5.
Okay.
And 5 is higher, which means that they'll decide to go in. So the equilibrium, when we talk about what's the equilibrium, we're talking about, well, what are the strategies that player 1 and player 2 are going to choose? The equilibrium in this case would be in for player 1 and accommodate for player 2.
It's not necessarily money. It's just like, where is everything 50-50?
Yeah, the equilibrium, we usually talk about equilibrium strategies. And so in this case, in equilibrium, player 1 will enter, player 2 will accommodate.